Good day everyone, myself Vedant Pingle. Today we are going to study about probability and types of probability distribution using mind map. First, what is probability? In simple terms, we can define probability as it shows the expected outcome of possible values for a given data generating process. Also, if we see mathematically, probability of an event A can be written as the number of favorable outcomes m upon total outcomes n. After this, we are going to see some important terms which should be known while studying probability. First, sample space. The set of possible outcomes of a random experiment is called as sample space. For example, if we take an example of a coin is tossed, uh, then the sample space of the coin can be written as uh, S is equal to, in curly bracket, heads comma tails. As in when we toss a coin, there are only two possible results, which is it will be either head or it will be tails. Then next one is independent event. Two events are defined as independent event if their joint probability is equal to the product of their individual probability. It also means that if there are two events, event A and B, and happening of event A has nothing to do with happening of event B, then it is called as independent event. Next is dependent event. Two events are dependent events if one event influences the probability of another event. For example, if there are again two events, event A and event B, and occurrence of event B is affecting the occurrence of event A, then they are both dependent event. Next is mutually exclusive event. The probability of either occurring is sum of the probability of each occurring. Then the events are mutually exclusive events. Also, we are going to see some terms. First, as we know, probability of event A can be written as number of favorable outcomes m upon total outcomes n. In similar way, there is also not happening of event A. It can be written as total number of outcomes minus favorable outcomes. So, the probability of not happenings of event A can be written as n minus m upon total outcomes, that is n, which also means 1 minus m upon n. As we all know, m upon n is the probability of happening of event A. So, this tells us that probability of not happening of event A is equal to 1 minus a probability of a happening event A. And we write probability of not happening of A event A as Q. So we get equation probability of happening of event plus probability of not happening of event is equal to 1. So the and if the condition is that the probability if the condition is when event is certain to happen, then the probability of not happening of event A becomes 0. In this condition, we take probability of happening of event A is equal to 1. From this we can say that the probability of any event lies between 0 and 1. As for the application of probability, we can take an example. We can calculate the probability of happening and not happening of natural disasters, or we can also find self forecasting from this. Thank you. Now I will hand over this presentation to my team.
Again, hello all. This is Rahul Savabade. So my topic is to binomial distribution and Poisson distribution. So let's go to the topic. Okay, let's talk about the binomial distribution, which is nothing but B of n p r, and the general formula is n e r p raised to r q raised to n minus r. So this is nothing but the binomial distribution. And also there's a term which is used in binomial distribution, that is mu, that is nothing but which denotes the mean of binomial distribution. Okay, I'm writing in short. And so mu is nothing but np, and variance, that is sigma square equal to variance, that is npq. Here in binomial distribution there is one note. So the note is nothing but is first one. Let's talk about p plus q equal to 1, and second one is p r equal to 1 minus p into r is greater than x. Okay, let's see what exactly the second note is tell us about, which is nothing but, if we take an example, that is p of r is greater than equal to 3, which is nothing but 1 minus p of r is less than 3. If we put this formula, we have to write all the three probabilities, which is r is because we have r is greater than equal to 3, so which is nothing but we will write as p of r equal to 0 plus p of r equal to 1 plus p of r equal to 2. So this is nothing but what the note 2 says. And the third note is p of r is greater than equal to x, which is nothing but p of r is equal to 0 plus p of r equal to 1 plus times p of x equal to r. So this is nothing but the third note, and this is about the binomial distribution. Okay, just now we completed the binomial distribution. Now let's talk about Poisson distribution. So let's go. Okay, in Poisson distribution, let me tell you the statement for the Poisson distribution. If when p be the probability of success is very small and n the number of trials, again n is the number of trials which is very large and np is the finite, then we get another distribution which is nothing but Poisson distribution. So if I say that when number of trials goes on increasing and p, that is probability of success, which tends to 0, so which tends to 0, such that the mean is finite, that is which is nothing but constant, that is NP is constant. So thus the probability of R success in a series of large number of trials with N and P, the probability of success at each trial, a small number which is given by P of R equal to Z raised to R e raised to minus Z upon R factorial. So this is nothing but the general formula for Poisson distribution. And here mean of the Poisson distribution is, so I will write in short PD, which is which I call Poisson distribution. So mean is equal to limit NP equal to Z. So variance is nothing but limit NPQ equal to Z. So which is limit Q is equal to 1, as I told you, that is P tends to 0. So therefore the standard deviation also we got is root of Z. So let me take one example for you because you get easily understand. So there's an example. So 1% of articles from a certain machine are defective. So what is the probability of number of defective? So we need to find the number of defective for 1% of articles from a certain machine, so which are defective. So second one is P, I mean one defective. Sorry about my handwriting because my handwriting is not good. So third we have to find is 2 or more defective in a sample of 100. So here P is I said that 1% of articles, so we got P is 0.01 and N is 100, because obviously 1% of article from a certain machine, that is P. If P is supposed to be 0.01, then N is obviously 100%. So N is 100, so mean. So we got mean, that is Z, which is nothing but NP equal to 1. So applying Poisson distribution formula, so we get we will get that is first defective. So obviously if there is a no defective, then P of 0 is e raised to minus Z raised to R upon R factorial. That is nothing but we have to put the value of Z R in place of Z. So e raised to minus 1, then 1 raised to 0 upon 0 factorial. So which will we will calculate by using calci. We will get 3679. So this is the value for no defective, and obviously for one defective, the probability of one defective is 1.
Hi friends, my name is Gulab Ahmad Sinde from Mechanical B Division. My roll number is 130, and my next topic is probability and probability distribution, and subtopic is normal distribution. So normal distribution is obtained as a limiting form of binomial distribution when the n numbers of trials is very large and neither P nor Q is very small. The most of the modern statistical methods have been based on the distribution. So